Hello, everyone. Let's wait one more minute till people gather. Maybe more people will come. I think today is going to be quite a nice lesson. Um, a big lesson, but um, a big in a good way. For some of you, this might be a completely new experience, and that is a good thing. For others, it might be an educational experience that you will find how to write proper tests. And in general, why do we really need tests? In either way, uh, I think this will be very useful. And basically, this chapter will teach you how to write code without bugs or with almost no bugs, and how to hack your way through coding interview as well. Uh, many things, and many lessons in this chapter. So there will be 7 lessons, and today's lesson will be about basics of xUnit, about the range act assert, why do you need unit tests, and what options do we have in .NET for testing. On Saturday, I'll give you a lesson about mocking and how do you test, how do you design for testability. Um, Lesson 3 will be about test-driven development and how you can hack your way through coding interview, or how you can buy yourself some time to think about design up front. Lesson 4 will be comparing integration and unit tests. We'll talk about black box and white box testing. Lesson 5 will be 2 really nice testing libraries. It's Fluent Assertions and Autofixture. Lesson 6 will be about patterns for testing, how you can refactor your testing code. And lesson 7 will be about other types of testing, not just integration and unit tests, more like end-to-end tests, how do you test front end, about QA tools, QA automation tools, and similar. What shall we talk about today? Today, I'll try to explain I'll try to cover main myths and facts about tests. Basically, what people think about tests, what's general opinion, and what they actually are for, and how they help. I'll explain about basic test steps, about what should be tested, what is a unit of testing, what you should and should not do when you're testing, about the 3 testing frameworks in .NET, NUnit, xUnit, MS Test, and about facts and theories in xUnit. So let's get to it. Myths and facts of automated tests. First myth, writing tests is a waste of time. So the way I'll present myths is I'll give facts that are true, that support the myth, but I'll also give in the next slide counter arguments that explain why is it a myth, why isn't it a breaking thing, why isn't it a bad thing, or why is it a neutral thing. So first myth, writing tests is a waste of time. It's true that writing tests is extra work that clients don't pay for. You don't get paid for writing tests. You get paid for getting job done. And job done is not defined by a written test. So writing tests is absolutely optional in business perspective. And you can simply test manually, which is fine in some cases. Well, it is needed in either way. But here is a study that is found in a book called So case study found in book called Art of Unit Testing. And one guy basically measured how long did it take to implement the same thing for two teams of relatively same skill level. Of course, this is something that you shouldn't completely rely on, that has no solid scientific base. Sample size is way too small. However, this definitely represent in some way the reality, because my personal experience matches what I see there. So, team without tests took 7 days. Team without a team with tests took 14 days. Let me send you the slides. And commenter. I also don't understand. Oh, here we go. Anyone with the link? Okay. Give me a moment. Viewer. Okay, copy link. Done. Google decided to change their UI, so I'm a bit confused now. Anyways, here's the comparison. Implementation. Your code future. Team without tests took 7 days. Team with tests took 14 days. Twice as long because they wrote tests. However, next step, integration. Different features come together. Bugs starting popping out. Team without tests, 7 days. They took longer finding bugs. They didn't know what was failing. They had to dig deep, do a lot of debugging, and it cost them time. Team with tests, everything was covered with tests. They ran tests, found bugs, fixed them fast. Easy. Testing and bug fixing. After integration, they put it in QA, in system test. Here we go. Testing manually takes the same amount of time, so it doesn't matter. However, fixing, since you have it covered with tests, it's very fast. So test, fix, and so on. Again, team without tests, 7 days, 12 days, team with tests, 7 days, faster. And overall release time for a given feature, team without tests took 26 days, and team with tests took 23 days. Less bugs in production, team with tests. Who's the winner based on this table? Team with tests. So, sure, writing tests here and now is slower, but having a bigger picture, having a longer term development in mind, it's definitely worth it, and you will save time by writing tests. And in fact, you will save your sanity as well, because you won't have to be a monkey who clicks and checks and does it again all over and over again. One click to see if your system is healthy. Of course, you must have in mind that having written a test doesn't mean that everything works. It just gives you overall health of system. If it's green, means that something is working. If it's red, means that that something is not even working. So it's definitely broken. And normally, from my experience, I would say that unit tests cover roughly 60% or so of systems ability to function. So if all of your tests are green, it's like 60% of system is working fine. If you add integration tests on top, I'd say 80-90% of system is working fine. Like, you can say that with certainty. But there is still the need of testing it manually to see if it's working for sure. So how does testing work? Why do we need tests? We basically click run all tests in your IDE via your test runner, and the end result is that it lights up. Your tests will be flagged as green or red. Green means it is working as expected. Red means expectation. The actual result did not match expectation. So another myth, why do we need tests if we test it manually anyways? So tester in normal big projects is a must. It exists. There is a tester, there is a QA person, and it basically has to pass certain layers before it goes into next environments, into pre-prod, and so on, into production, and so on. So features are going to be tested manually by a tester, and even a tester can make mistakes, therefore QA will test it afterwards, and even they make mistakes, and therefore we have bugs in production. But that doesn't matter. Regardless of the fact that tests are imperfect, they still act as a documentation. It's not just a way of double checking, it's a way of understanding how a system works. So imagine you have a string calculator, a calculator which calculates how much, what is a sum of numbers given in a comma separated string. So what happens if you pass an empty string? Well, based on the requirements, many things can happen. It can throw an exception, it can return -1 being invalid, it can return 0 being valid. It really depends. However, a single source of truth could be tests. You look at the test and you can understand how the system behaves under certain conditions. And tests are written, should be written in a way that it's clear what is passed and what is the result. What is passed, called, and what is the result. So here you can see I have a calculator that is static and I call sum function. So to sum function I pass an empty string and I assert whether my actual sum was 0, the expected. And my test name, if I collapse this test body, then the name of my test explains what I'm testing. So it says sum when empty, number string. So sum is what I call, when is what I pass, and returns is what I expect. Return 0 is what I expect. And I have those 3 steps for arrange, act, assert in my test, and it's represented in the name. If you look at tests, they are documentation. They speak for the system, under what condition it works and under what condition it doesn't work. Another myth. Changes are more difficult. Imagine you have tests, and imagine your tests rely on some interface, and that interface changes. It requires different kind of input. So your tests inevitably changes because you have to adapt the tests to pass the right input. Or worse, tests changed and you tested so deep, you tested every function call inside the body, and you simply don't call those functions anymore, so your test breaks as well. Changes in code do require changes in tests. That is true. And sometimes I heard so many complaints that TDD is just broken, don't do it, because there's so many changes and those changes are just tedious. However, is that really a problem of tests, or is that a problem of poor design? So if you verify every function call, that is testing implementation. Our tests are not supposed to test implementation, they're supposed to test business logic. And business logic can be, let's say, a critical service was called, a critical thing was logged, a an expected output was returned. Those are business logic things. And if I just called service X, service Y, service Z, that's just implementation. If my requirement doesn't say, if in my user story, it doesn't say call this service explicitly, I shouldn't test it because business doesn't care. However, imagine the opposite. You come to a legacy system, and from my experience, all legacy systems have zero tests. You just test new stuff, but the old stuff you leave behind, you settle with it that it's untested and leave it like that for the time being. There are ways how to improve that, but that's out of scope of this lesson. Anyways, untested waters. How often do you make changes in a legacy system? The answer is you don't. And the reason for that is because there is such a high risk that you broke something, and there is such a high risk that you broke something without knowing that you simply don't want to do it. You don't want to take that risk. That is legacy system. It's too risky to make a change in a legacy system because it's not tested. With tests, we can run them and immediately have feedback if we broke anything or not. Not just our own code should be tested in the same loop of tests, but the whole system. And it should be fast, immediate. So with tests, we can make changes in even an old system. Another thing, another myth, writing tests is not worth to the business. Business says, why are you taking the unnecessary time just being perfectionist and testing your code? Tester will do that for you. Why does that matter? Just do your thing. We need to do a release in a week, so you don't have time. Just hurry up and do your job. Testers, developers are all being under pressure of business, and they sometimes give in. And actually, if testing is executed poorly, eventually management will come to you and say, this is not working out, and we're cutting it off from you. And if that happens, who is there to be blamed? Tests or developers or business? Well, definitely not tests. It's just poor execution of them, poor implementation. It's management for putting too much pressure, and it's developers for giving in to that pressure. However, if you don't test your code, if testers test code, and if they still miss a part of bugs because they're humans, where do you find your bugs then? If they end up in production, what happens to a bug that ends up in production? A customer will write an email. That email will end up to some business person. That business person will come to team lead. The team lead then contacts the team members or testers. The testers then try to find the bug, reproduce it. They then give a report to the developer, and then the loop continues until the developer gets the steps that needs to be reproduced, or even worse, finds it out themselves how it broke and then fixes it. How much time do you think would it have taken if developer wrote a unit test or integration test? And how much time do you think it took them to manually debug and find the broken place? Well, the answer is it's literally dozens of times slower compared to writing a test. So if you find something, and here is a very interesting chart actually. If you design something very well, and if mistakes happen in design early on, you can fix it. immediately for nearly no effort. But the longer you develop a feature, the lower down the line it goes, the deeper it goes through the pipeline, it costs more and more time to fix bugs. And it's not just time. You make commitments, you made agreements. So this might not only be time cost here, but it might also mean that you will pay some fines for breaking commitments. You committed to writing code that doesn't cause critical problem, that doesn't leak critical things. So if you break those commitments, it can be as well way more than 30 times. In any way, that's why planning is important. In requirement stage, you try to design something that will fit your needs, even a good enough solution, but something that will likely not change, at least not majorly. And in coding step, you cover the bugs with unit tests. In integration environment, testers cover the bugs. In system acceptance testing, QA people test your product, your software. And finally, you don't want to end up here. And I think it's not 30 times, it's 100 times here. It's bad, horrible, and you don't want that. But it happens. As long as it's not critical, I guess it's not horrible. Anyways, if you catch it here, that is great. But it takes 5 times longer because you need to adjust the requirements, the architecture. If something like a bug, like mismatch of architecture needs fixing, that is the only reason it takes so long here. Yeah. Right, so if we look here, we detect bugs early, 5 times the effort. If we detect here, 30 times the effort. So no bugs in life, business will be thrilled. They'll be happy. They will love your work. Do they expect that? I actually don't know what this business expect. I am not sure if they're optimistic or pessimistic or being statistical and realistic. But tests, writing tests helps for business to keep their good name, to deliver bug-free software, or strive to at least, and to discover bugs early and save money and time like that. Next, some people say that tests require a specific design, like they complain, I wrote this code and it's untestable, so I now need to change it. Sure, that is true. Tests do require specific design. They don't allow you to have hard dependencies on things. They, like, you cannot easily test big components that are coupled, and sometimes people even write code just for testability inside, like, let's say add flags if testing, I'll do this and that. But changing your source code just for writing tests is not the best thing. That just implies that you misunderstood something, that your design has uh, flaws. And that doesn't mean that tests require a special design. That just means test requires you to keep it clean. So tests enforces best practices, in fact. So you shouldn't complain about something that enforces good things on you. That's not a bad thing if you look at it that way. It becomes a bad thing when people overdo it and when they think that unit test is the only answer to writing an automated tests. Sometimes an integration test is good enough. You need to measure the effort and the benefit and make a certain decision based on that. Unit testing 100% everything is absolutely stupid. It's not worth it. And it doesn't even make sense in some cases because you cannot test it with certainty. So you have to add layers and layers of tests. Some parts of code will be unit tested. Other parts of code will be integration tested. And there are more types of tests that we'll talk about later that help us ensure that our code is actually tested. But it's not that we apply the same kind of tests throughout whole code base. If it breaks the design horribly, we simply settle with a different kind of test. Next, people say that it's not even an argument, but people say debugging is a skill that you should be proud of, that is very useful. And I don't argue with that. Some people say, I don't write tests because I can just debug, but that also doesn't matter. Debugging is inevitable, and that's a fact. However, and this is not breaking a myth, this fact by itself is just stupid, but I'm not breaking the fact. You will debug the code. However, with unit tests, you will debug less. Because if you have a single piece of code tested, a single function in isolation, for example, if it fails, you'll know immediately where to look. You won't need to look at the client, which called a service, which called a function. You'll just look at a single function which was called and which failed. So a single source of truth that you'll find in unit tests. So even if you do need to debug, you'll know exactly where to put the breakpoint, exactly where to step into, which is your act statement. So if you're fixing it, 100% you know where to debug. Really easy, fast, convenient. Next, developers don't need to write tests if they are testers. It's true that testers check the features that developers make, regardless if developers write tests or not. And they do it in a variety of ways, usually both automation for end-to-end tests and manual testing for just double checking if it really works. However, it's different kind of things that testers and developers tests, and it's different kind of things that testers and developers have in focus. Developers are focused on their own thing, on their own code, and often in isolation. Testers test stuff in integration environment where a feature is now a part of a system. And that is a huge difference. So developers write unit tests, integration tests. Testers write performance, penetration, security, end-to-end tests. And it's very different from one another. Both are needed. Testers to ensure that what developers made works in integration, and developers to giving proof that their code works for other team members, other developers, and double checking. Next, you cannot rely on automated tests because testers will manually test code. QA will do the same after the testers did that, and then it will be again interacted with in production. That's true. However, The more tests you have, the less the risk is that a bug will go through to production. Every kind of testing, starting with unit tests, with testers tests, and with QA manual testing, adds a layer of protection, a safety net to stop bugs from coming. So the more, like the the faster you catch a bug in the inner layer until it reaches the outer layer and finally production, the cheaper it is for the business and both for you, time wise, money wise, to develop, to fix it. One more layer of protection. That's what tests, automated tests, are. They are not something you rely on, again, they're not something you rely on 100%, but they are a layer of protection. Now let's talk about what a unit test is. Here is how unit tests sit in a pyramid of tests. You see at the top of the pyramid, tests increase quality assurance. You see at the top of pyramid, you have GUI tests, which are just a small fraction of all tests. Then a good fraction of tests is integration tests. And at the bottom, you can see that the most common kind of tests are unit tests, because they are for functions, for classes, or other things in isolation for a unit under test. Unit tests one thing in isolation. Why do we need to test one thing in isolation? Because we don't want overlapping tests. Because if it fails with isolated test, we'll know where to look for failure. It will be way easier to manage. What is a unit in unit test sense? There is a misconception that a unit is a function, strictly a function with all dependencies cut off. And that is not true. It really depends on what you're testing. And having dependencies even in unit test sometimes is not so bad, and it still can be called a unit test. So unit test, or in general tests, will always test something in isolation, and it has varying levels of has various levels, starting from function, class, feature, and being as complex and high level as a component. So you could potentially even test a class or a feature and call that a unit test. The criteria is that it's still fast. It doesn't affect other parts of the system, like it's still a single component in absolute isolation. It's still a single feature in absolute isolation, a class or a function, absolute isolation. That is the key point. If it starts interacting with systems that are completely different, then it's no longer a unit test. Then it's integration test. Jamie12 said, I've stopped saying unit test for this reason. I always try to use spec test to show that I'm only ever testing a feature in isolation, not individual functions. That's a great point. I also stopped having a distinction between unit or integration tests. What's the point of calling them? It's just a name. All that it matters is that a thing is tested, nothing else. And that is the problem, that people are just stuck upon dogmatic ideas that everything should be unit tested. And then they ask themselves, what is a unit test? And then they start mocking everything. And then they end up testing mocks themselves, which is illogical and it shouldn't happen, but it happens. and it breaks code base. It makes it a mess, and people still do it. I don't know why. Anyways, test case is the core, basically a single test method. Uh, Tests are written in methods, just like any other code, and a single method in test is called test case. It's not a method under test, but it's the test itself. So here imagine we have a chicken, and chicken can walk based on three conditions. If chicken walks calm, a chicken can move based on three conditions. If it's calm when it moves, it just walks. If it's scared when it moves, it runs. When it's stuck, it stops and doesn't move. So it ignores your movement command. And each of those three things are test cases for chicken movement. We should write test cases for not only success, but for failure as well, for edge cases, so that we have a full specification under what conditions it works as expected and under what conditions does it fail. And for test names, for having the need of test names to be very specific and representing exactly under what conditions happen, they tend to be quite long names. In the test name, you should write everything that the test, basically you should write what method you called, what method you called, under what conditions, with what arguments, and what is the expected result. So I called method move when chicken state was calm, and the result was that chicken walked. I called move when chicken was scared, the chicken runs. I called move when chicken was stuck, nothing happened. So I read those three test cases, and without inspecting test body, I know what happened. I know what to expect. Test suite is the class that holds all the test cases. So test suite is the container for test cases. So imagine you have a chicken test suite for all the functionality a chicken can have. So what can a chicken do? Chicken has 1, 2, 3, 4, 5 methods. Chicken can lay eggs, eat, sleep, move, and cluck. If it clucks, it's trivial. It cannot fail. It just does it and it makes the cluck sound. If it lays eggs, there are two conditions. When chicken is fed, it can lay eggs properly. If chicken is hungry, laying eggs will not return an egg. Nothing will happen. If chicken is scared, you the chicken will if chicken eats a worm when he's scared, if he eats one worm, it still makes him hungry. It's not enough, so he needs to eat 2 worms to feel full when he's scared. However, when chicken is stable, 1 worm is enough. So we can make a conclusion that when chicken is scared, he needs to eat twice as much. And if chicken eats one worm more than he needs, he becomes overeaten. And next, the chicken needs to sleep 12 hours. If he sleeps less or more, he'll feel tired. He or she, let's not be sexist. And those are just repeated cases. So chicken test suite, fully tested chicken, would look like this. Yeah, I can use they, but I suck at using that. I should though. True, it's a she. True. But that's very technical though. Let's continue. So what are the best practices for writing tests? Here are my recommendations. Do interact with system on the test once. Like you're testing a single method. Well, whatever you're testing should be called once normally, unless your test explicitly tested that calling it twice fails or not. So in any case, act step is calling the system once. You shouldn't ever leave tests, uh, you shouldn't allow tests to change your environment. Or at least it's okay to allow them to change the environment, but you should clean up after yourself. If you modify the environment, something that persists, you should clean up after yourself. Otherwise, it can affect other tests or the same test. Tests should be fast because the whole point is to run it and have immediate results. If tests were slow, you wouldn't, your feedback loop would be slow as well, and it wouldn't be so attractive, so comfortable to writing tests. And make reproducible tests. The point of tests is a proof that your code works and that it works not only on your machine but on other machines. That's why we have pipelines where tests are being run as a proof that it works. So people can review your code and say, code works, it looks good, I approve. Doesn't just work on my machine. Prefer single assert per tests and keep tests locally. Like, don't go into integration environments if you don't have to. Just prefer to keep them locally, and prefer not to check too many things in a single test because that blurs the point of test and that makes it harder to keep track on what they are for, on what they are actually testing. Avoid shared test state and big test fixtures. For example, avoid having a full database for testing purposes if you're testing something that doesn't need a full database. For example, if you're testing if you can add, let's say, an item to an existing order, and if that is allowed by the business rules, all you need is an order, a person, and maybe existing order lines, but that is it, nothing else. So keep it minimal in tests and don't be redundant, because if you start creating environments for tests, it will grow ugly and unmanageable too soon. And I've faced that myself from my own experience. Don't allow tests to affect environment in any way. That is a biggest no. Basically, clean up after yourself. That's what you should do. And now, tests. Every single test, 100%, runs these 3 simple steps. And it's called AAA strategy for testing. That every test has arrange, act, assert steps. And no, it's not this kind of AAA, though it is a good thing for keeping a reference. So arrange step means that we're setting up our environment, our system under test. Here, it means, imagine we're testing if you read a book that you were supposed to read. So our setup step is taking a book. Our act step is actually reading a book. And we check edge cases if, let's say, a book was broken, if it had no pages, if you actually mistook the book for another. and we then assert if the book that you were supposed to read was the book that you actually read. Let's say a teacher asks you, asserts whether you read a book, and you say, yes, I did. And here's the contents, or here's the title and description, and so on. How does that look like in code? Or what options do we have? And there are three frameworks in .NET that we can choose from for testing. It's NUnit, MS-Test, and xUnit. I chose those pictures as representation of what is each test representing. NUnit being the oldest, most trusted, featureful, experienced, and existing in multiple languages. MS-Test being quick and dirty. That's all I'll say about it. And xUnit being the newest, professional, clean way of testing. So, NUnit exists in multiple languages. In .NET, it came in 2002, the first thing with which we could run tests. MS tests came in 2005 after NUnit. Basically, Microsoft wanted its own testing framework. Like always, they want their own things, and they made something that failed horribly. It failed horribly almost immediately in like 2010, but then it was revived by open source community, and they made it okay-ish. MS Test 1 was horribly slow, was working poorly. MS Test 2 is similar in terms of speed, but to me it's still quite ugly because there's a lot of staticness involved. Next, xUnit, the latest one, came out in 2008 for .NET. And the funny fact is that the guy who made NUnit made xUnit. So after he made NUnit, he said, I can do a better job. So he made xUnit. That happened in 2008. So the choice for this bootcamp, for this chapter, is to base our lessons, our tests on xUnit. Why? Because it's clean, it's object-oriented, it enforces best practices, it's self-documenting, because tests are either facts or theories, and it enables neat design, which minimizes the code we need to write for tests. How does a test look like? A fact. Test that does not need parameters. Move forward is a method that a chicken has. Let's say we want to test if chicken moves forward as we expected. A chicken is created by giving it an initial state and initial location. Vector 0 means that it is at 0, 0, 0 position in terms of x, y, z coordinates. If I move forward, given I'm stuck, my location should not be changed. So my test name says exactly that. Move forward by 1. When stuck, I stay in place. What happens? Chicken move forward 1. My initial location matches current location. I'm in place. I assert this, and it's either correct or not. And that is a fact, no matter by how much I move. In fact, I shouldn't even pass 1 here. I should actually pass anything. It doesn't matter by how much I move. I still stay in place. So this test name is actually a bit wrong because I should eliminate this 1 here. It shouldn't matter. Well, however, I should pass something more than 0 because if I don't, it means it could be a false test as well. So I should be mindful to what I pass. So I should pass anything that's more than more than 0. All right, theory. For theory, outcome depends on input. And here you can see that I have a test. It's a theory. And here you can see that I pass arguments for this test, because how the chicken's location changes will depend on how much they on what state they were in, not so much on what uh, location, um, or what direction or at what speed they were moving. So therefore, all I need for this test is to pass a state and verify expected location. Minimalistic. Minimalistic also means that I don't pass 100, 1,000, a million. One, a single one is enough for verifying the behavior. A chicken moves by 1 unit forward, and I check for expected location. And how do I feed the parameters? And those parameters are complex because vector is not a primitive, it's an object. And therefore I couldn't write primitive. Well, you'll see in the next slide what I'm talking about. Anyways, I feed the arguments like this. I'll explain in detail how this works, but I'll just look at the test input. When I'm stuck, my location remains vector 0, the initial vector position. When I'm stable, I moved by 1 unit. When I'm scared, my speed was doubled, so I moved by 2. Theory input. As you noticed, inputs in theory comes from attributes. This is an attribute which feeds the input for theory. And every input there is an attribute. Every input there is an object. So it's a bunch of objects that you feed into a test. It is not strongly typed. It's just an object, as you can see here, and as you would see in inline data. So it doesn't match it. The attribute is not matching the parameters per se, but when you're running the test runner will match them together. You can mix the types, you can have less or more arguments, and it will compile in most cases. However, when you will run the test, it will complain if you have, let's say, just the state passed when here you exposed a state and location. Back to the attributes. Inline data is the most simple way of passing arguments in tests and theories. It is used for passing primitives. Imagine you're testing summing 2 numbers. And I think you cannot have any more edge cases than here for summing. If you sum 2 different numbers, you get the sum of their numbers. If you sum something with 0, the 0 gets ignored. If you sum 2 zeros, you get 0. If you sum 2 same numbers, you get double that number. Those are all the possible cases for summing 2 numbers. Oh yeah, negative. Sorry. Let's say it's uint and not int. Let's say it's uint. But yeah, negative is a good point. And that's a very good thing. Basically, you miss edge case like this, and what happens is that you deliver a bug. Normally, if you write it properly, what you tested is actually tested properly and the test covers the functionality. However, you often, due to human behavior, due to human nature, miss something because you cannot know all the edge cases right away. And you cover those edge cases when you find bugs. When you find a bug, you write a test for it, you test it, fix it, and deliver it back to the pipeline. Anyways, inline data is parameters for primitives. Member data is exactly the same as inline data except for objects. However, it behaves completely different in a way that you pass arguments through an attribute that comes as a member. It can be either a method or a property, and in this case, it's a property. A get-only property that has to be static, has to be public, and it has to return an enumerable object array. Interesting thing here is sometimes people just create a new array which holds a bunch of new arrays. This is wrong approach because this means that you create a bunch of sets for tests and just iterate through that and get feed them one by one to the test. This is bad because it's not lazy loaded. If you want to save memory, if you want to optimize it a little bit, it's enough to have lazy loading. So here in this case, it basically says it can be iterated through. However, if I take the first element, if I iterate it through and I take the first thing that comes, only then the first thing will be created. If I take the second thing, only then the second thing will create it. And if the first thing is not used, I won't care and I won't keep it in memory. And that's how enumerable works. You just lazy load the input that you need. And this is especially valuable when your input is complex. Anyways, public static enumerable of object array is the definition, is the declaration that you must give a member or function that provides, supplies test input. The most simple one is just the read-only property with a bunch of yield return new object array statements. And here you can very clearly see all the cases how chicken movement behaves. If the chicken is stuck, it remains at the initial position. If chicken is stable, it moves by 1. If chicken is scared, it moves by 2. And instead of 3 facts, I can write a single theory with 3 sets of arguments that I'll pass to my test, and the test itself will remain exactly the same. Also, another benefit of using arguments is that you see here, I no longer need to create initial location here. It comes from an argument. And it just gives clarity. As you know, test is 3 steps always. And here I can clearly see 3 steps. I also recommend putting a blank line in between those steps at least. If we go back here, I didn't put a blank line between here because it's still these 2 lines are part of the same block of code, which is arrange. And this is act, and this is assert. And each is separated by a blank line. Some people even go an extra mile and just put a comment. And actually a comment is a great thing when the test becomes big. But then if a test becomes big, your test should be simplified. If we go back to do's and don'ts I will add one more thing, and I'll say don't add complicated logic to tests. It's an essential thing that I should have mentioned. Keep it simple applies so hard to tests. I think it's the best example of keep it simple in tests. It's absolutely prime example of what should be kept simple. And that's why writing tests can be quite a different and awesome experience, because you are allowed to experiment and refactor and apply different patterns for tests. And that might be a quite funny and fun thing for a programmer. Just practice. And that's one more benefit of tests. We're not monkeys. We don't like manually doing stuff, manually clicking, testing, and so on. We are programmers, developers. We like writing code. So practice instead of clicking manually like a monkey. Write code, be developer, not a monkey. Last way of passing parameters is through class data. It's essentially very similar, as you can see here, to um, um, member data. However, it is in a class, as the name suggests, and it needs to implement enumerable of object array. And you might ask yourself, why would I use that over the other one? If you share the same set of parameters across different test suits, use the same class data. That is one case for it. Or if setting up the input and the expectation is so complex that it requires a class of its own, that otherwise it would obscure the test suite itself, also class data is in that case good. And that is all I wanted to show for this lesson. And I'm not sure if we should even go for live coding today, because it's just a bunch of theory and nothing to actually show, because the code examples that I show for the scope of this lesson, I wouldn't show anything more than this. Now, do you have any questions? Okay, that's very cool. But anyways, right, when would you not write a test? That's a very good question. Um, if something is being tested in a way that it doesn't give me certainty anyways that the unit I test, and that unit being might be, let's say, a controller method in integration with the framework. Let's say if I check if it has an attribute, if it validates a certain attribute based on the framework thing, or if it processes everything in one go, I would consider maybe uh, testing it differently or testing it manually, if otherwise it costs me too much time. So for highest level components, I would consider a different approach, not always automated approach. Also, for testing something that a framework has already tested, I wouldn't write a test because it's already tested. So I wouldn't test the logic that would be related to that framework specific stuff or something that I can see that was tested. And if I'm being pressured on time, I will also not test all the edge cases. I'll just test the happy path scenario. It's not a perfect solution, but it's a pragmatic solution that you go for when you are short on time. And I always ask this, so please write one thing that you think you understood very well in this lesson and that you would like to understand better or are curious about, like a certain thing in this lesson. Maybe a highlight, would like to know more. I'll give you a few minutes. I'll go grab a drink. Right. Starwalker said more on the difference to unit test and integration tests as they are often confused. As shown in slide number 2, we'll cover those in detail in lesson 4. But for now, I can just say in short that unit tests are testing something in isolation or trying really hard to test it in isolation. And integration tests is when instead of, so when you test something in isolation, you basically escape dependencies, and there are different ways of doing that. Sometimes you use different dependencies that you yourself make. Sometimes you use mock objects. And when you apply those techniques of escaping dependencies, faking them, that's unit testing. And when you are testing in integration, that means you now don't avoid the dependencies and just write tests for code as is and feed the dependencies that there are for a given component. Aurora said, I think I understood the process of tests well, arrange, act, assert, and so on, but I'd like to know how other kind of tests are done. I imagine there are tests to make sure an exception is raised on some conditions. Yes, there is. And we will talk about those tests in the second lesson. How to verify not only the output, but also the behavior. What happened inside. So what I showed here today is called black box testing, and what you're talking about, what happens inside, is called white box testing, like as if you pass a function for an X-ray and test what happens inside. Chapter 1 versus Chapter 3. So if you're asking what TDD is, that is just a strategy of writing tests. You can choose to write tests at the start before writing code, or you can choose to write tests after you wrote code. And TDD will be focusing on how do you write tests before writing code. So it's like egg and chicken kind of problem. and I'll try to explain why is that good, writing tests first, and how do you do it. Jamie12 said, I'm not really here to learn the basics of testing, just want to get more opinions on it since it's the topic I feel passionately about. I would be interested in where you draw the line between testing individual features versus large features at a high level. For legacy system, I would definitely test large features without caring much. And I would slowly try to put those components, features under adapters, put them to an interface so that I can test the rest stuff under a unit test. And when I have isolated that thing that starts working, maybe I'll try slowly replacing that with something new. That would be my approach. Now, if it's a new thing, if it's something I wrote, I think it depends on the complexity of the thing. If it's something that was made on time pressure and therefore there were many design mistakes, and if properly implementing that cleanly would cost too much time, I would also not care much about testing in too much isolation. I would just write an integration test and test it high level in not the greatest detail, because it's a tech debt, and for testing something that is tech debt that will change anyways, you don't really care. Oh, great question. Would you ever test a private method, an internal class? The answer is no, I wouldn't. I wouldn't add an attribute to make it a friend class as well. I would consider, why is it an internal thing? Why is it not public? For private, it's quite straightforward. If it's a private method that needs testing, then you should consider making it a public component that is privately referenced in your class as a component if it needs testing. For internal class, I probably think I wouldn't bother. It's an implementation detail. I don't want to mock that. I don't care about escaping that. It's a part of implementation. I don't expose it, so I don't care. People sometimes test it, but I think it's a big part of other features, so I wouldn't care. We'll talk about more about things like that in second lesson. Um, so testability, what to test. Starwalker said, I'm honestly really against doing that, against testing internal or private methods, or are you for testing them? Yeah, okay, same. All right, so next lesson we'll talk about how to use MockQ, mocking framework, mocking library in .NET. We'll talk about how to mock stuff, how to verify if something was called, how to verify if something was called with the arguments you passed, how to set up fake classes, and how to design so that you can test a thing in isolation. Thank you for your attention, your time, for watching, and see you on Saturday in lesson 2, mocking and testability. See you for now.